In this video, we're going to talk about problem solving and rational equations, and in particular, work problems. So looking at this first example here on the left, it says, at KeyBank, it takes a computer 4 hours to process and print monthly statements. When a second computer is used and the two computers work together, the statements can be printed in 3 hours. How long would it take the second computer by itself to process and print monthly statements? So the way we're going to set up these problems is about defining the rate at which work can be done. So I'm going to set up the rate, and we're talking about two different computers. I'm going to call it computer 1 and computer 2, and the two computers together. So the way computer 1, it says it takes 4 hours to process and print monthly statements. So it can do one job in 4 hours, right? So one set of documents in 4 hours. Computer 2, we don't know. We know, or that's what we're trying to find, how long. So it can do one job in, we don't know how much time. So time is the variable. Then when we look at the two together, it says it takes them 3 hours. So again, they can do one job, or one set of documents, in 3 hours. And then using these rates, we can make our equation. So the rate that computer 1 works plus the rate at which computer 2 works will be the rate at which they work together. And now we have a rational equation that we can solve. First, we have to identify the least common denominator. Looking at 4, t, and 3, the LCM of 4 and 3 would be 12. And then there's also the 12, or the t, that we have to include in part of our LCD, since that is a distinct factor in the denominator. Now, we need to make each denominator look like 12t. So what do I have to multiply 4 by to make it look like 12t? I have to multiply by 3t, denominator and numerator. So now 3t times 4 would give me 12t. What do I have to multiply t by to make it 12t? I have to multiply by 12. Numerator and denominator. Then lastly, what do I have to multiply 3 by to make it 12t? I need to multiply by 4t. So now we would have the following equation. 3t times 1 is 3t. 3t times 4 is 12t. 12 times 1 is 12. Over our 12t equals 1 times 4t is 4t. Over our 12t. And once all of our denominators are like, we can clear out the denominators. We would just need to multiply everything by the LCD. That's 12t. And the denominators will all divide out. And what we're left with is just the numerator. I now have 3t plus 12 equaling 4t. I solve for t. I want to get all my t's on one side. So I subtract 3t from both sides. I'm left with 12 equals t. So that means that the second computer can complete and process those those statements in 12 hours. That's the units. Go ahead and try the other 3 examples by defining the rates and then forming your equation. Alright, let's look at this example on the right. It says, Greg can paint a room alone in 3 hours. His brother Philip can do the same job alone in 5 hours. How long would it take them to paint the room if they worked together? So again, we're talking about 3 different things. We have Greg's rate that he can work, his brother Philip, and their rate together. So Greg can do a job alone in 3 hours. He can paint one room alone in 3 hours. And then Philip, it takes him 5 hours. So again, same job in 5 hours. We want to know how long it will take them together. So they will do one job in, we don't know how much time. So again, it's the job over the time. You do one job in 3 hours. One job in 5, one job in we don't know how long. Sometimes what I see students do is try to find the average of these two and just say, oh, well, if it took him 3, it took him 5, then it must be 4. But let's go ahead and solve and see what happens. So the rate at which Greg can work plus the rate at which Philip can work will be the rate at which they can work together. I have to identify the least common denominator. 3 and 5 have no common factors along with that t, so it ends up just being 15t. I want to make all my denominators look like that. I need to multiply 3 by 5t. Oh, that's not really dark enough. Get a brighter color. So 5t. I have to do the same thing to the numerator. The next denominator, 5, I have to multiply by 3t. Numerator and denominator. And then the t, I need to multiply by 15 to make it 15t. Once all the denominators are the same, then I don't need the denominators anymore, right? I can clear out those denominators. And this is why, because I can multiply everything by the LCD and the denominators would divide out. Now I'm left with 5t times 1, just 5t, 3t times 1, 3t, that will equal 15 times 1 is 15. I combine my like terms, 5t plus 3t is 8t, and then I undo the multiplication with division. So t equals 15/8 hours, which we don't say, I'm going to do a job in 15/8 hours. So I'm going to go ahead and convert that to a mixed number. 8 goes into 15 one time with 7 left over. So 1 7/8 hours. Or we could even change that to a decimal by dividing. So if I divided, I would get 1.875 hours. So it just depends on what your question is asking and if there's anything in the directions that tell you how to leave your final answer. Let's look at the next problem. Here, it says Isaac can put in flooring in 12 fewer hours than it takes Phoebe to do the same job. Working together, they can do the job in 8 hours. How long would it take each working alone, I should say alone, to put in flooring? Alright, so we've got Isaac, and we've got Phoebe, and we've got together. So the question is, what's the variable? I know that Isaac can put in the flooring in 12 fewer hours than it takes Phoebe to do the job. I don't know anything about how long it takes Phoebe to do the job. So that's the variable, is Phoebe can complete the task, one task, in I don't know how much time. But I know something about Isaac. So Isaac can do it in 12 fewer hours than it takes Phoebe. So whatever her time is, I want 12 fewer hours. So those are their rates. So she can do one job. I don't know anything about her time. He can do one job, and it's 12 hours less than however long it took Phoebe. Together they can do the job, it says, in 8 hours. So now I have the rates for each one. So the rate of Isaac plus the rate of Phoebe will equal their rate together. There's my rational equation. Now I need to identify the least common denominator. It looks like, so this is all one factor. There's nothing else I can factor out of that, so that is a factor. This is factored. This is just a set of 2's. Everything here is distinct. So my LCD is actually each one of these multiplied together. And I need to make all of them look like that least common denominator. So this has the 12 minus t. It needs the 8t. So I'm going to multiply by 18 and 8t in the denominator, 8t in the numerator. This has the t. It needs an 8 and the t minus 12. The same thing in the numerator. Sorry, my computer froze for a second. Minus 12. And then this has the 8. It needs to be multiplied by t and t minus 12. Whatever I do in the denominator, same thing in the numerator to keep it equivalent. So this is all multiplication. Alright, they all have 8t, t minus 12. 8t, t minus 12. 8t, t minus 12. Once all the denominators are the same, I can multiply everything by the LCD and clear out those fractions. What is left is 8t times 1. So 8t. 8 times 1 is 8 times that 8t minus 12. So I'm going to go ahead and just bring it down. I'll distribute in a moment. And then 1 times t is just t times t minus 12. Now I've got an equation that I can solve. I would start by distributing wherever there are parentheses. So I have 8t plus 8t minus 8 times a negative 12 is negative 96. T times t is t squared. T times a negative 12 is negative 12t. Now I'm going to combine my like terms. I see I have a 8t and a 8t. Oops, I lost my square here. That should be t squared. Combine those. 8 plus 8 is 16t. And then from here, I see I have a t squared. And this means it's not linear. I need to get everything on one side and try to factor. So I'm going to go ahead and subtract everything from the left and move it to the right, because I want to keep that t squared positive since it's the highest degree. Then from there, let's see what we have now. So this is 0, 0. My left-hand side is 0, which I wanted it to be. I have my t squared, and then negative 12t minus 16t is negative 28t plus 96. So now I'm looking for factors that multiply to 96 and add to negative 28. So right away I know that if it's going to multiply to a positive, it either has to be two positives or two negatives. And since I want it to add to a negative, they have to both be negative. So I'm looking for two factors that will both be negative and multiply to 96 and add to negative 28. So factors of 96. Well, we already know 12 and 8 go in, but that's not going to get me to 28. So what about 24? 96 divided by 24 is 4. So all I did was I said, I know that 12 and 8 can't go in, since that's how I multiplied to get 96. And since that didn't work, I took a 2 from here, from this factor, moved it over to that factor, and that's how I got the 24. And then I divided to figure out the other 4, and I know that those add up to 28. So I'm going to make them both negative, so it adds up to a negative 28. My leading coefficient is 1. I can go right into my two sets of factors. It's t times t would give me t squared, and the factors we found were negative 24 and negative 4. So I set each one equal to 0 using the zero product property. And solve for t. So that means that t could be 24 or t could be 4 hours. But we have to stop and analyze our answers, so we can't have two different answers here. It takes Phoebe either 4 hours or 24. It can't be both. So going back up here to where we defined our variables, if Isaac takes 12 hours less than Phoebe, this can't be the answer. Because if I plugged in 4, 4 minus 12 would give me negative 8. People can't work in negative time, so this is not the solution. And it is 24 hours for Phoebe. So that's Phoebe, because her time was just t. And Isaac can do 12 hours less than Phoebe, so he can do it in 12 hours. And there you go. And now, let's look at one more. This one is about a faucet filling up a container and draining. So it says a faucet can fill an empty sink in 6 hours when the drain is open. The sink will empty in 10 hours. How long will it take the faucet to fill the sink if the drain is left open? Okay, this one's a little bit different than the other ones, but we're still going to talk about the rate at which something will empty and the rate at which it will fill. So we've got empty, the rate it will fill, and when we do both, when it is draining and the faucet is on. So a faucet can fill an empty sink in 6 hours. So the rate at which it can fill fill one sink in 6 hours. Then it can, when the drain is open, the sink will empty in 10 hours. So again, one sink takes 10 hours. Now the both is what we're trying to figure out. It says how long will it take if the sink to fill if the drain is left open. So one sink, we don't know how long. Now we're not going to add these two rates together because one is filling and one is emptying. So it's going to be the rate at which it can fill minus the rate at which it's emptying, right? So this is positive because it's going in the sink, and this is negative because it's draining the sink. So this rate minus that rate is going to be their rate together of where it ends up full while this drain is left open. So let's go ahead and solve this now. I'm looking for the least common denominator, and I have a 6 and a 10, the least common multiple of 6 and 10. I could list them out, 10, 20, 30, 30. So 6 goes into 30, 10 goes into 30. So 30, least common multiple of 6 and 10, and I need the t, right? So there I have the LCD of all my denominators. I'm going to make all my denominators look like that. I'd have to multiply 6 by 5t to make it 30t. Same thing in the numerator. Then 10 needs to be multiplied by 3, and don't forget the t, also in the numerator. And then take my t and multiply it by 30 to make it 30t. Again, once all the denominators are 30t, so 6 times 5 times t, 3 times 10 times t, and 30 times t. They're all 30t. I can clear out those denominators. Again, the reason is because I can multiply everything by the LCD, and they would divide out. What's left is the numerator. 5t times 1 is 5t. 3t times 1 is 3t. And 1 times 30. Combine my like terms. 5t minus 3t is 2t. Divide by 2. And t must be 15. And since all of these are in hours, my units are in hours. And there you go. So, the way we do any kind of work problem is we figure out the rates at which each item or person can work, and then we make our equation either by adding the rates to get the rate together or subtracting, depending on the context of the problem.